So I said that the heating and cooling method was a little different than a standard unit out there on the market. This unit actually uses a Peltier heater cooler, and what a Peltier is, it has two different materials, and based on the way that you're passing electricity through those materials, it will either pull heat into the system or suck heat out of the system, unlike a compressor. Now, a compressor, it actually works with refrigerant and a compressor, and what happens is you're using electricity to compress a gas. When that gas expands, it sucks energy out of the surrounding atmosphere, therefore lowering the temperature. Um, so it's more of a digital type control. It's either on or off. You can't run a compressor type system at 50% because it just won't work. It has to run at 100% or off. And I actually have one of the Peltier units right here. So this is it. This is, I'm not sure what size this is, but this takes the place of all that refrigerant and tubing and a heater. Yeah, there's no resistive heater inside the system to then add heat to the system. This does it all. Electricity is passed through here, and depending on whether it needs to cool or needs to heat, that's which way the electrons will flow. And you can run this at 10%, 50%, 100%, and it does a really nice job at maintaining the temperature at 22 degrees. I don't know if you can see that. It's right at 21.9, and it stays very tight to the actual set temperature. We did a lot of real-world testing with these in heat chambers and high humidity to make sure that there wasn't any issues, but this is actually a mission critical Peltier. They use these in a lot of power distribution boxes and military equipment, so that it's a very rugged solid state device. There's no moving parts on this except for the fans, where a compressor has the compressor, which is constantly running, and has the refrigerant, which can leak out and has to be replaced. So it's a much more efficient, much more robust design than a compressor.